As we continue on here, another thing to be aware of in C++ is what is referred to as pass-by value. This starts on page 322, and this employs in a textbook what I call the reverse importance ratio. The more important a concept is, the smaller the dedication it gets in a textbook. So C++ does not prefer to allow bad things to happen. As a matter of fact, it so dislikes the idea that something might happen while data is being interchanged from one function call to its function location and back. If you think about that, right? So C++ on line number 22 sends data over to line 4000. That data on line 4000 gets 100 lines of code where things are being moved around the greater program, and then it comes back and it returns to line number 22. What happens if somewhere in those other 1,000 lines of code, what happens if somewhere in all of the processing that's happening in the background as C++ is working with memory locations that Chrome is happy to gobble up? What happens if the data that C++ sent is corrupted and is dropped or never returns? What happens to that data? And as we all know, it goes nowhere. There is no way for C++ to recover that. So in order to avoid catastrophe, what C++ does by default is what is referred to here, 6.5, again, page 322, as pass by value. So if I am in, and we will see this in the code in just a moment, if I am here inside of my int main, and I am going to pass to display a display function of value that I wanted to display. What I'm not going to do is take the location in storage of the original value and give it over to my function to do something with. What C++ would much rather do is look at the variable and its storage location. You're an int, your value is, let's say, 4. Is going to take a copy of that value, a copy of a 4, and is going to take that over to my display function. And here's a copy of that value. Now, if the function does something wrong, never responds. If the function does something wrong, tries to overwrite it. If the function does something I'm not expecting, turns an integer into a color value, something else, there's no catastrophic consequences of that, because way back on line number 22, that variable that we were referring to, value, is still got the original value of 4 stored in it. So pass by value says C++ by default always wants to take a copy of that value. Here's a 4. I'm going to take a copy of that 4 and give that copy away. So here in program 6.9, we'll just go through really quickly. 6.9 on 322. So first and foremost, you can see again our function prototype on line number 7. It's a void, so it returns nothing. Change me, and it receives an int. That's its parameter list. So here on line number 11, int number equals 12. So inside of main, my num, in this case it's my int rather, number, has a value of 12. So inside of main, I output the value of number is, and it outputs 12. So then here on line number 18, I make a function call. I call to change me, and I pass it as an argument number. What I'm doing is passing by value. C++ says, okay, number refers to this int that I have in a storage location over here. What is the value that's stored in there? 12. I copy this 12, and I'm going to pass the copy to change me. So here, during runtime, while this is being executed, after C++ encounters this change me line here, and it takes that copy, we come here to line number 31, where the parameter is int my value. So inside of change me, the parameter, so remember, in int main, it's an argument. Here in change me, it's a parameter. The parameter is going to be referred to as my value. My value gets the value of the copy of the int number from main. So now my value has a value that is 12. So here I am on line number 24, my value equals 0. So on line number 31, or I'm sorry, 31, we have created a new int variable with the name my value. It has a value of 12. That is coming in as a parameter. Now we have changed the value of my value to 0. So we have taken that 12, we have made it a 0, and here inside of change me, the value is now 0. So we're going to display, now the value is 0, and that is from inside of change me. So we reach at line number 38, we reach the end of this statement block. C++ returns us here to line number 18, and it encounters that semicolon, so this line is done. And here, inside of main, on lines 21 and 22, I am going to show you the value of number, and it is still 12. You can see the output happening right here in the program output section that you guys can't see. It's too low. There we go. In the program output section, you can see here. And again, this is still on page like 323. So what is happening? C++ never really gave change me the function the int number. It gave it a copy of int number. Inside of change me, you could do whatever you want to that copy because it's never passed back to main. It's a void function. So whatever you do inside of change me only happens inside of change me. It's just like Vegas. Whatever happens in change me stays in change me. So when we go back to main, there has been no change because we took a copy of number, we gave the copy away, we never got the copy back. C++ knew that because it's a void function. It's great. I got a copy. Here, number is still in its original location with its original value, and it has been untouched by the rest of the program. That's not necessarily how every program all the time wants to work, but it is the default state for how C++ manages data internally. C++ manages data internally by what is called, and here it is again, pass by value. C++ would rather take a copy of a value and make an additional storage location than it would risk my original value being screwed up. It seems like that's a long way around the block for something, but it's the default behavior for C++, which means it's something that you as a developer absolutely positively have to know.